Next, we talk about the other type of product of vectors which we call as a cross product, also named as a vector product. Now, we should understand that since in case of dot product the answer was coming out to be a scalar quantity, we called it a scalar product. On the same lines, now we are calling cross product a vector product because the result of cross product of two vectors is going to give us a vector quantity. Okay. So, cross product between two vectors is written as A cross B, and the defining equation for the cross product is A cross B is equal to A B sin theta into n cap, where A B sin theta is an expression similar to what we have got in dot product, A B cos theta there, here it is A B sin theta. A here is the magnitude of vector A, B is the magnitude of vector B, theta is the angle between the two vectors. The new thing here is this unit vector n cap, which gives us the direction of the cross product of vectors A and B. So, this part of A cross B is the magnitude part and this is the direction part, right. Now, how do we get the direction of A cross B? There is a method, there is a rule that we use to get the direction of A cross B, which is the direction of vector n cap, and the direction of vector n cap is given by what we call as the right hand thumb rule. N cap is given by the right hand thumb rule, and we shall discuss this now, what is right hand thumb rule and how does it give us the direction of n cap, the direction of A cross B. Okay. So, the right hand thumb rule, if we discuss now, according to the right hand thumb rule, if we take our right hand and stretch our fingers perpendicular to the thumb. So, we take our right hand, let me try and draw a figure for this. This is the thumb and these are the fingers of our right hand, let us say. We stretch our right hand in such a way so that the thumb is perpendicular to the fingers which are stretched. And then we curl these fingers from the first vector to the second vector. So, when we are doing A cross B, we first keep our fingers of the right hand in the direction of the first vector and then we curl those fingers in the direction of the second vector, and in the process of that curling, the direction in which the thumb points gives us the direction of n cap. So, let us see this using an example, a figure. Let us say this is vector A in a certain direction and this is vector B in another direction. Now, if we are supposed to find out A cross B, that means we first need to point our fingers in the direction of vector A. That means our fingers of the right hand will be pointing in this direction and then we will curl our fingers in the direction of vector B. As we do that, you can try doing it here as I drawn this figure on the screen. You can take your right hand, stretch your thumb and the fingers, keep your fingers first along the vector A and then curl them towards vector B, and as you do that, you will see that your thumb is pointing perpendicular to this plane and coming outward, out of the plane will be the direction of your thumb. That means it will be towards you. So, in this case, the direction of the thumb will be outward, and that outward means outside the plane of the screen, which is perpendicular to this whole plane of the screen. That is the direction of n cap, outward to the plane of the screen. Okay. So, this is how we get the direction of n cap. Let us draw another figure to understand this a little better, because we are working in 3 dimension right now, but using a 2-dimensional screen to understand that. Let us say this is a plane and it is this plane that contains the vectors A and B. So, this is vector A and this is vector B, both of which lie on this plane that we have drawn here. Now, when you take your right hand and take your fingers along the direction of vector A and then you curl them in the direction of vector B, you will see that your thumb is pointing perpendicular to this plane like this. This will be the direction in which your thumb will be pointing. You can try doing this, and this is the direction of n cap, perpendicular to the plane containing the two vectors A and B, and in such a way so that the right hand thumb rule is possible, because understand that if we see here, the vector n cap is perpendicular to the plane containing vectors A and B, right? Now perpendicular to this plane, this vector is also perpendicular, right? The vector that I draw downward is still also perpendicular to the plane. So why are we choosing only this? Because this is coming from the right hand thumb rule. When we use the right hand thumb rule, it gives us the precise direction of n cap, which is the direction of A cross B. Okay, as we shall see questions based upon this, it will become more and more clear to us. So now that we understand this, we can look at a few cases now. One could be, what will happen if theta, the angle between two vectors, is 0 degrees? Do you understand? If theta is 0 degrees, then the cross product of two vectors, which is given by A, B sine theta into n cap, sine theta will be 0 because sine 0 is 0. So this will be 0. So we see that in case two vectors are parallel to each other, their cross product is 0, right? Whereas if the angle theta between the two vectors is 90 degrees, that means A cross B will take its maximum value. Why? Because the value of sine theta is highest when theta is 90. Sine 90 n cap, which is just AB into n cap, which is the highest possible value, right? Magnitude of A cross B will be maximum here because sine theta is taking its maximum value. Okay, so these are a few observations that we can make from here. We can also try and find out the cross product of a pair of unit vectors. As we have done in case of dot products, we can try finding out I cap cross I cap, j cap cross j cap, k cap cross k cap, and so on. All the possible combinations we can work upon. Starting with I cap cross I cap, do we understand that by definition, I cap cross I cap will be modulus of I cap, which is 1, into modulus of I cap, which is 1, into sine of angle between I cap and I cap, which is 0 degrees. Sine 0 is 0, right? So the answer will be 0. Also, we know that for two parallel vectors, the cross product is 0, and I cap and I cap, since they are equal, they are obviously parallel to each other. Similarly, now we know that j cap cross j cap will also be 0, and k cap cross k cap will also be 0, right? On the other hand, if we take other set of pairs, for example, I cap cross j cap, if we take, for this we will have to work upon things. For why? Because I cap is a unit vector along the x axis, right? And j cap is a unit vector along the y axis. If you look at things carefully, if you try to use the right hand thumb rule as you do I cap cross j cap, you would be taking your right hand, stretching your fingers and thumb perpendicular to each other, keeping your fingers first along the I cap direction, that is this direction, and then you will be curling them along the j cap direction. And as you will do that, you will see that the direction of your thumb is perpendicular to this plane which contains x and y axis and is coming out of the screen of out of this plane of the screen, which is along the z axis. This is how we define z axis, right? Which is perpendicular to the screen coming out, and when x, y axes are there on the plane of the screen. So, in this case then, do we see that n cap, which is a unit vector in a direction which is perpendicular to both I cap and j cap, will be nothing but k cap. K cap is a unit vector which is perpendicular to I cap and j cap and is coming according to the right hand thumb rule. Please see for yourself this carefully, spend some time on this and see how right hand thumb rule works, and is giving us I cap cross j cap as k cap. K cap is a unit vector, right? We are looking for a unit vector only. So this is how we get the direction of I cap cross j cap. Now similarly, we can try for j cap cross k cap. J cap cross k cap means your fingers are first along the y axis and then you are curling them along the z axis. Now you have to keep your fingers according to the figure. This is a 3-dimensional figure, so you have to work carefully here. When you curl your right hand, the fingers of the right hand from the j cap direction to the k cap direction, you will notice that your thumb is pointing along the I cap direction, that's along the x axis. So j cap cross k cap will come out to be I cap. And if we look at the third pair, which is k cap cross I cap, see that k cap is now along the z axis and I cap is along the x axis. So when you take your right hand, once again stretch your fingers, point your fingers first along the z axis and then curl them along the x axis. You will observe that your thumb is pointing along the y axis. So k cap cross I cap will come out to be j cap. I hope you all understand that magnitude wise both I cap, j cap and k cap, all the 3 unit vectors have a magnitude of 1 and all of them are perpendicular to each other. The angle between them is 90 degrees. So if we talk about their magnitudes, the magnitude will be 1, the magnitude of I cap into the magnitude of j cap into sine of 90, which is also 1. So the magnitude of each of these is always 1 and the directions are the other unit vectors. So everywhere I cap cross j cap will be another unit vector k cap, j cap cross k cap will be the third unit vector I cap and k cap cross I cap will be the third unit vector j cap. So this is an important result, knowing the cross product of any pair of unit vectors and finding out the corresponding result in terms of the third unit vector. Understand that instead of doing I cap cross j cap, I could have done j cap cross I cap. So we can see what happens there. To get the answer for that, we can first understand whether cross product is commutative or not. When we write A cross B, which is A B sine theta into n cap, what shall be B cross A? B cross A shall be B into A into sine of the same angle between the two vectors into this time the new unit vector, let's call it n cap dash. Let us see what happens to the direction of B cross A. Taking the same example that we have taken above, see that when we have vector A like this and vector B like this and we do A cross B, we will be curling our fingers from vector A to vector B and the direction of n cap will come out like this in the upward direction. Try doing the same thing now by first pointing your fingers along the vector B and then curling them towards vector A. You will see that when you try doing that, you will have to take your right hand and put your thumb in the downward direction. Only then you will be able to curl your fingers from vector B to vector A, not otherwise. So if you try doing that, automatically your thumb will now be pointing downward. So the direction of B cross A will not be the same as the direction of A cross B. It will rather be just opposite to the direction of A cross B, right? So this n cap dash is nothing but minus of n cap. And we understand from here that the cross product of two vectors is anti-commutative. A cross B is minus of B cross A. Why? Because magnitude wise the two will have the same value, but the direction of A cross B will be just opposite to the direction of B cross A. Hence this result. And now that we know that cross product between two vectors is like this, we can connect them like this. We understand that if I cap cross j cap is k cap, then j cap cross I cap will be minus k cap, right? So I can write k cap as minus of j cap cross I cap. Similarly, j cap cross k cap is I cap. So we understand that k cap cross j cap will be minus I cap. So I can write this as minus of k cap cross j cap. And similarly, this value will be k cap cross I cap is j cap. So this will be minus of I cap cross k cap. So cross product is anti-commutative and we can like this get the values. Now these results that we have obtained here are important. We are going to use them into questions. So let us try to get a kind of formula or a shortcut method to get the values of cross product of any pair of unit vectors. For this we use a certain way, a diagram that helps us understanding and remembering the values. What's this diagram? We just draw a circle. On that circle, in a certain sense, either clockwise sense or anti-clockwise sense, we write the 3 unit vectors I cap, j cap and k cap equally spaced from each other. And in whatever sense we have written the 3 unit vectors, we draw arrows on the circle in the same sense. So since I have written them here in the clockwise sense, I have drawn arrows also in the clockwise sense. Now, according to the rule, when you take the cross product of any pair of these unit vectors, the answer will be given by the third unit vector with a plus sign if you have moved in the direction of the arrow in the process of taking the cross product, and with a minus sign if you have moved opposite to the direction of arrow in the process of taking cross product. Let's understand this taking an example. Let's try to do I cap cross j cap. I cap cross, for doing I cap cross j cap, I will have to move from I cap to j cap. And in the process of moving from I cap to j cap, I have moved in the direction of this arrow, right? So the answer for I cap cross j cap will be equal to the third unit vector, which is k cap, with a plus sign. Why a plus sign? Because we have moved in the direction of the arrow. On the other hand, if we do j cap cross I cap and try to do that by moving from the vector j cap to the vector I cap in this figure, in the process of moving from j cap to I cap, we have moved opposite to this arrow, and so the answer will be still k cap but with a minus sign now. So this particular figure helps us remember these formulae very easily. Anyway, as you continue to practice questions and all, it will automatically, you'll be able to remember the results automatically and you'll be able to use them. Okay. So using these values now, I cap cross j cap cross k cap and so on, let us try and find out the value of cross product of two vectors in one more way. Another formula when the two vectors are given in their rectangular component form. A cross B, finding A cross B when vectors are given in their component form. Component form. Component form means, just recall we have done a similar exercise in dot product. Vector A is given as Ax I cap plus Ay j cap plus Az k cap, and vector B is given as Bx I cap plus By j cap plus Bz k cap, and we are trying to find out the cross product of these two vectors. A cross B is what we are supposed to find out. So when we try to do this, we will be writing the two vectors as Ax I cap plus Ay j cap plus Az k cap crossed with Bx I cap plus By j cap plus Bz k cap, and then we will do the whole distributive multiplication that we did in cross product, in dot product also, right? So when we do that, we will be getting the first term will be Ax I cap cross Bx I cap, plus the second term will be when we take the cross product of Ax I cap with By j cap, Ax I cap cross By j cap, plus the third term will be Ax I cap cross Bz k cap, and so on. Now we take the Ay j cap component and take its cross with all the three components in the second bracket. So plus Ay j cap crossed Bx I cap plus Ay j cap crossed By j cap plus Ay j cap cross Bz k cap. The third row now, Az k cap cross Bx I cap plus Az k cap cross By j cap plus Az k cap cross BZ K cap. Now, reminding what we know, just recalling things that we did in dot product. Here we have I cap cross I cap, which is 0. So the first term will go away. I cap cross J cap is K cap. Right? This we have just now obtained above. I cap cross K cap, as you will see, you can find it out, it's minus J cap. We can use our formula method, this diagram as the formula to get the values. I cap, J cap, K cap, putting the arrows. I cap cross K cap, understand we are moving opposite to the arrow, so it will be minus J cap, right? So similarly, we can get all the possible cross products. Let us write their values one by one. So the first term, because I cap cross I cap we have here, this will be 0, plus the second term is AXBY into I cap cross J cap, which is I cap cross J cap, which is K cap, plus the third term, which is AXBZ into I cap cross K cap, which we have just now seen, it is minus J cap, right, plus the next term now, this one, J cap cross I cap. J cap cross I cap, as you can see from this particular figure, J cap cross I cap will be minus K cap, and then along with that you have AYBX into minus K cap, plus look at the next term, it's J cap cross J cap, which we know is 0, so this term is going to 0, plus the next term is AYBZ into J cap cross K cap. J cap cross K cap is a plus I cap, plus the next term, the third term over here, AZBX into K cap cross I cap. K cap cross I cap, we are moving in the direction of the arrow, so it will be plus J cap, plus the next term here, AZBY K cap cross J cap. K cap cross J cap, we are moving opposite to the arrow, so I cap with a minus sign, plus the last term, AZBZ, but K cap cross K cap, which is a 0, so the last term will go to 0. See that we have got 6 non-zero terms in this expression, and each one of them is such that we have either a I cap or a minus I cap, J cap or minus J cap, K cap or minus K cap associated with it. So let us contain the I cap terms together, the J cap terms together, and the K cap terms together. First, the I cap terms, this is a term containing plus I cap and this is containing minus I cap. So we can write AYBZ minus AZBY into I cap, right? Next set of terms containing J cap and minus J cap, this one and this one. So AZBX minus AXBZ into J cap, and the third set of terms containing K cap and minus K cap plus AXBY minus AYBX into K cap. This is the final expression that we are getting for the cross product of two vectors A and B. Ideally, you are supposed to remember this expression, but see that this is too large an expression to remember, right? So we have got a shorter method of remembering this expression in the form of something that we call as the matrix form for the cross product. A cross B, we can write it in a matrix form, a 3 by 3 matrix which contains 3 rows and 3 columns. What are those 3 rows and 3 columns? Just understand this carefully. The first row contains the 3 standard unit vectors I cap, J cap, K cap. The second row contains the three components of the first vector, which in this case is vector A. So, Ax, Ay and Az. And the third row of the matrix contains the three components of the second vector, the vector B, Bx, By, Bz. So, if you just remember this particular form, we can easily find out, or we can easily deduce this expression of cross product between two vectors. How do we do that? We should know how to open up this matrix as well to get the same expression that we have obtained above back. So, let us understand how we open up this matrix. To solve this matrix, we start with the first term of the matrix, the term contained in the first row and the first column, which is I cap. So, write I cap here and then open a bracket. As we do this, we are supposed to leave the row and the column that contain I cap. So, these two, the row and the column, the first row and the first column leave away, and then you cross multiply the terms containing in the remaining 2 by 2 matrix. So, it is AYBZ minus AZBY. This is how you write them. You cross multiply and then you put them with a minus sign in between. So, AYBZ minus AZBY. This becomes your first term after trying to open the matrix, the first term of the matrix. See that it is the same term that we have in this expression for A cross B above. Okay. Now, how do we go further opening up the matrix? Now, we take the second term of the first row, the J cap component. We write J cap. One important thing that you need to remember here is that when you write J cap, it has to come with a minus sign. This is something that you have to remember. So, J cap is written with a minus sign, and then you do the same thing that you have done in the first part while finding out the value of the I cap component. So, what you do is you leave the row and the column that contains J cap and you cross multiply the rest of the terms and put them with a minus sign in between. So, in this case, see carefully that when you cancel away or you take away these terms, what you are left with is AXBZ to be multiplied together minus AZBX. This is what you get in the second term. Look at this expression carefully and see that this is the same as this particular term that we have obtained in A cross B expression. So, this is the same thing. Next, the third term, K cap term, will come with a plus sign itself, and you do the same thing that you have done with the first two. So, you leave that row and that column which contains K cap and you cross multiply the remaining terms and you put them with write them with a minus sign in between. So, AXBY minus AYBX becomes your expression for the K cap component. See that it is the same term that we have obtained here. So, see that writing cross product in terms of a matrix gives us the same expression back that we have obtained analytically above. This might look as if it is like a really complicated expression, but if you are able to write the vectors in the matrix form while calculating the cross product, you will see that it becomes quite simple to solve the question containing cross product. We can just look at an example to understand this. Let us say vector A is given by I cap plus 2j cap plus 3k cap, and vector B is given by 2i cap minus 2j cap minus k cap. I have just taken some values for the sake of reference, and we are supposed to find the cross product, find A cross B. Now, what we do is we write the cross product in the matrix form. We write A cross B by definition is the first row contains I cap, j cap, k cap. The second row contains the components of the vector A, which is 1, 2 and 3. So, 1, 2 and 3. And then the third row contains the components of vector B, which is 2, minus 2 and minus 1. 2, minus 2, minus 1. And now let us open up this matrix to get the cross product. Starting with I cap, open the bracket, leave the column and the row that contains I cap, cross multiply the remaining terms, put them with a minus sign. You will get 2 into minus 1, that is minus 2, minus 2 into 3, which is a minus 6. Do this carefully without making any mistakes in the signs. Next will be minus j cap, open the bracket, leave the row and the column that contains j cap and cross multiply the remaining terms. So, here we have 1 into minus 1, that is minus 1, minus 2 into 3, that is 6. This becomes your j cap component. And the third term of the expression is plus k cap, open the bracket, leave the row and the column that contains k cap and cross multiply the remaining terms. So, you have 1 into minus 2, that is a minus 2, minus 2 into 2, that is 4, and done. You just have to simplify this expression now. See that minus 2 plus 6 is plus 4, so you will have a 4i cap. Minus 1 minus 6 is minus 7, but then we have a minus sign outside, so it will be plus 7 j cap, and minus 2 minus 4 is minus 6, so minus 6 k cap. This is our answer for A cross B. See that we don't have to remember that long expression for the cross product of vectors. The matrix form gives us a very easy way out to get the cross product between two vectors.